Hey everyone, Mr. Russell here. In this video, we're going to go over how to write our solutions in interval notation. Okay, so if you need help with either solving and or compound inequalities, or if you need help with graphing, please see one of the other videos. Here we're just going to focus on how to write our solutions in interval notation. Okay, so I'm going to start here by looking at these first two examples. Let me just bring this screen back up so I don't get too distracted. And we're going to look at our OR compound inequalities to start. So I have one that's written as just the inequality and one that's just as a graph. So I personally have always found it easier to write interval notation after we have the graph. I'm just a visual person. I like to see what the solutions are, which is what graphing does. And then from there, I like to express my answers in interval notation. So what we're going to do is I'm going to take this first inequality here, and I'm just going to quickly graph this. Okay, x is less than or equal to -2, or x is greater than or equal to 3. Okay, so I'm going to graph both parts of that because we know it's an OR compound inequality, so our graph has two parts to it. So I'm going to start by graphing x is less than or equal to -2. Okay, less than or equal to tells me I have a closed circle at -2. And since x is less than that, I want to show all the numbers that are smaller than -2. All right, there'd be my solutions to the first part of that graph, or first part of the inequality. The next one, x is greater than or equal to 3. Same idea. So since it could be equal to 3, we're going to put a closed circle at 3. And since I want x to be greater than or equal to 3, I want to graph all the numbers that would make that statement true, which is everything to the right. All right, so we have our graph. Now from there, interval notation is really just reading the graph from left to right and saying where the solutions start and then where the solutions stop. Okay, so if you look at this graph, go all the way to the left and ask yourself, what is the smallest possible solution? Well, since this arrow is pointing to the left, that means our solutions are going infinitely smaller all the way to the left. So that means our solutions start at negative infinity. Now, when we use an infinity, positive or negative, in interval notation, we always put a parenthesis around that. The reason being is because we use a parenthesis in the same way we use an open circle, and that represents that that number is not actually a solution, right? We don't actually equal that number in our solutions. And infinity and negative infinity is not a number we can count to. We can never actually equal positive or negative infinity, so we always use a parenthesis around positive or negative infinity. Okay? And now I want to say where my solutions stop, right? Here's where they start. They start way off in negative infinity. And then where do they stop? Well, it looks like we stop at, bam, -2. All right, so I'm going to put a -2 here. Now I want to say, do I use a closed or an open circle? I'm sorry, do I use a parenthesis or a bracket? Well, since I have a closed circle at -2, that means -2 could be a solution, and that means we're going to use a bracket. Okay, we use a bracket whenever in the graph we use a closed circle. Okay, and then we kind of have a gap in our solutions. Okay, so there's two ways we can do this. You can either put a U that represents the union. We haven't talked about that too much. Or just write the word or in between kind of where that gap is. And now our solutions are starting again at 3. All right, so I start at 3. I'll put my 3 here. And there's a closed circle at 3, which means 3 could be a solution. And just like at -2, since there was a closed circle here, that told me to use a bracket at -2. A closed circle at 3 tells me we're also going to use a bracket at +3. And then my solutions go off to infinity. Ooh, that's a terrible infinity symbol. Let's make that look a little better. Ooh, now we're erasing. Oh my goodness. All right, a little better. And around parentheses, we always use, or around infinity, we always use a parenthesis. All right, second one. So the graph is already here, which is nice. So I'm just going to go right from there. So say, okay, where do my solutions start? Well, we're starting way off at negative infinity. So I'm starting at negative infinity. We know we always use a parenthesis around that. Okay, and then we're stopping at 4. Okay, so at 4, or sorry, -4. So I put a -4 here. And now I have an open circle at -4. All right, so open circle at -4 means I want to put a parenthesis around that number. Okay, and then or where do my solutions start again? We're starting at 0. I see an closed circle at 0, which means we're going to use a bracket. and then I go off to infinity. There we go. All right, so there's our interval notation for our OR compound inequalities. And notice, I mean, it really matches up with the graph. If I was to bring this interval notation over, I don't know if I can do that. It matches exactly what's happening on the graph, right? We're going off to negative infinity. We're stopping at -4. We're starting at 0, going off to infinity. And that's on purpose. It should always match what's happening there. Okay, and if you want to, here's the inequality that goes with that second example. All right, next, let's talk about the and compound inequalities. Okay, so here, our first one says, let's see, x is greater than 1 and less than 5, or x is between 1 and 5. So again, I would start by graphing that. Okay, so x is greater than 1, not equal to, so open circle at 1, open circle at 5, and it's all the numbers in between there. Okay, essentially saying x is between 1 and 5. So just like before, for interval notation, let's say where our solutions start and stop. So nothing goes to negative infinity, right? I don't have any graph over here. My graph starts at 1. So since our graph starts at 1, our interval notation is also going to start at 1. So I start with a 1. Bam. Now, do I put a parenthesis or a bracket around it? Well, since we have an open circle, okay, or my inequality itself, x was greater than, not equal to, so I use a parenthesis. And then where do my solutions stop? Well, they stop at 5. Again, open circle at 5, so I put a parenthesis around it. That's it. Graph starts at 1, ends at 5, right? No arrows going off to infinity in either direction. So infinity is not being included in this interval notation. The second one, same idea. All right, so we're starting at -3. So I'm going to start with -3. Now, since I see a closed circle at -3, we're going to put a bracket around that number. Okay, and then my solutions go between there and stop at 1. I see an open circle at +1, so I'm going to put a parenthesis on that +1. And if you'd like, here is the interval notation to match up with that. Okay, so that's everything for interval notation, guys. Key things to remember is I use a parenthesis whenever we use an open circle on the graph. I'm using a bracket whenever we use a closed circle. Okay, and then besides that, read your graph from left to right and match up your interval notation the same way. All right, let your teacher know if you have any additional questions, and thanks for watching.